Well, hello. And today we're going to be looking at a new base, base E. We've looked at multiple bases with different numbers, and then we zeroed in on base 10 and learned that for base 10, we don't have to write the base. It's an understood, also called a common base. Today we're going to look at base E, and base E is just another base. Prior to this, I did ask you to do a reading a little bit and try to process what E is. And you should have read that E is an irrational constant, similar to pi in the sense that you know about pi and have worked with it in geometry and then probably some in middle school. Unlike pi, which is 3.14159 and change, E is 2.718, 281828459. So some of you in the reading mentioned that there was a mnemonic to help you remember that, or a poem to help you remember it. Anyway, you're not going to have to memorize E, but it is irrational. It is also sometimes known as Euler's number. He was the one that really gave it its first formality and used E, although there are many other mathematicians that used it kind of without knowing. So Napier, probably the first, the one who developed logarithms back in, like 1620. So Mayflower was happening here in the United States. John Napier was over in Great Britain doing logarithms. So really cool stuff. Anyway, it's just another base. And so in the same sense that with base 10, common log, we don't have to write 10 down. Base E is used so frequently that it is also one we don't have to write down. It occurs naturally, I would say. It occurs in many places. And so because of that, it gets its own designation. So we are looking at, we'll say base E, and I will write it that way, okay? And then natural logs. And natural logs also have, natural logs are the inverse of base E, just like logs and exponentials are inverses of each other, but these have their own way to express. So natural logs, probably when these were first written about, again, from Napier into Bernoulli, into maybe Leibniz, and then some of the other writers, Euler, much of the scientific writing was done in Latin because Latin didn't change. And whether you were a scientist in Germany or a scientist in France or a scientist in Great Britain, you would have known the Latin language. And so it was probably the educated world language before. Now it's probably English, but anyway. So because of the way it probably was written in Latin, which in English we use the adjective first, natural log, so adjective noun. In Latin and some other languages, they put the noun first and then the adjective. So it would have been logarithmus naturali. So that probably is the reason that we now we don't write NL, we write LN. And if you look on your calculator, right here, we've used this log button, the one right by 7. We've used him. And again, that's understood base 10, right? That's base 10. So look right underneath it, and then you see LN. So that's natural logs, base E. And if you look in blue on the little toggle switch above it, you see e to the x. On this log button, up above it in blue, you see 10 to the x. So again, this is the common log button. This is the natural log button. These are your two log buttons. So you think about everything that's on your calculator. That's quite a bit designated just for logs. That tells you how powerful they are. But base 10, base E. So it's just another base. It looks different when we write it. It's just another base. Approximately 2.7. Okay, approximately 2.7. It models continuous exponential growth, and that is important. Okay. Can you hear Chopin in the background? That's what I'd like to be doing, is just playing the piano. But we're doing math today, so that's all right. I can listen to Chopin. So all the things that we do with regular logs and exponentials, we can do with natural logs and exponentials. All the same property holds, so that's good. You don't have to learn anything new. It's just going to look different when you're doing it. Instead of writing log, you're going to write ln. Instead of writing base 2 or base 10 or base some other number, you're just going to use the letter E. The trick, though, it plays a trick on your mind. We're used to seeing a letter and thinking variable. Got it. Okay, that's not the case here. E is not a variable in the same way that pi is not a variable. Looks like a letter, so we get confused in that. Not a variable. It's an irrational constant. Okay? So let's just do a few examples. Alrighty. One of the things that we can do is to write equivalent expressions. And if you are working in your book, which you should be, right? If you are in your book, this is about, let's see, this is page 501 to 508 in your book. Alrighty. So we can write equivalent expressions. In other words, we can rearrange from log form to exponential form and from exponential form to log form. Just like we could with other bases, just like we did with base 10, we can do the same thing with base E. So we'll start out with something like this. E to the x equals 9. Now notice it doesn't say solve for x. It doesn't. Okay, what does it say? Write equivalent expression, which means rearrange. If it's in exponential form, you're going to put it in log form. If it's in log form, you're going to put it in exponential form. Okay. So you're just going to rearrange either in expo or log form. All right. So this is my base. The exponent in exponent form is the log value in log form. This value over here, the 9, becomes the argument when I put it into log form. So let's rearrange. So I could say this, log base E of 9 equals x. I could do it that way, but math to the rescue. If we can do it more simply and elegantly, we will. So, look at here. That's 4 letters, log base E. We have another way to write that. So instead of writing log base E, we can do this. ln of 9 equals x. And those two things are equivalent because log base E is the same as ln. Those two things are the same. And when we write ln, it's an instant recognition, or it will be, oh, we're doing base E. Okay. When you see the word log, you tend to, now this is not wrong, log base E. It's not wrong, but you're not going to see it written that way. If you need to write it that way at first, that's fine, but you're going to see it written this way, ln, natural log. And again, the base is understood because it is natural log. All right. So for us to rearrange it, they just want us to, if it's an exponential form, they just want us to put it in log form. So this is just a musical chairs. Everybody moves to the spot. So again, this is the log value. The exponent form is the log value in log form. This is the base, understood down here, right? And then the value in exponent form becomes the argument. And again, remember, why does this happen? Because logs and exponentials are inverse functions. And with inverse functions, the domain and range switch places. And that's what's happened. Okay, so rearrange. Let's do another rearrange. All right. If I have e to the 7th equals x, and again, they're not asking us to solve. What are they asking us to do? Rearrange and write an equivalent expression. Okay, so what am I going to do? Well, I'll say log or ln base e, don't have to write that, of what? X equals 7. Okay. You can also rewrite logs into exponentials. What would that look like? Well, if it starts out as a log, the ln of x equals 2.1438, okay, 6. If you start out with it like that, it is in log form. What do they want us to do? Write an equivalent expression. So we're going to rearrange it. We're going to put it in exponential form. So you're like, what is the base? Oh yeah, it's ln, base e. So when I rearrange that, what do I get? I get e to the what? This is my exponent now. So that's the thing. Remember, logarithms most of the time are not whole numbers. They're long irrational numbers that we just whack off at about 5 places. So be my friend here, Pen. So you're going to say what? E to the 2.14386 equals, the argument in log form becomes the exponential, the value of the e raised to the power, right? Rewritten. One more, just for grins, okay? 1D, what do we have here? Let's say the ln of 18. So you have one where the variable is in the argument, and then you have one where the variable is over here, the log value. So again, it's not asking me to solve that. So be careful when you look at your instructions. What is it asking you to do? And in this time, they're just asking me to write an equivalent expression, which means rearrange. So now I'll put it in exponential form. All right. So what does that mean? Yes, I need more time to clean my room. So what does that mean? That means I'm going to say base, so e to the x equals 18. All right, all the log properties and abilities that we have either in base 10 or the other bases work for base E.